Hello and welcome again. So, in the last class we started using Scilab software. So, I told you how to do some very simple operations like adding and multiplying. Now, we will look at some of the constants in Scilab. Several constants are there in mathematics. So, they have a specific representations in Scilab. So, I will give this example. For complex number, you know that you have x plus I y. So, that I is an imaginary number square root of minus 1. So, that is represented as percentage I in Scilab. So, percentage I means imagine a number which is a square root of minus 1. The next one is this e, remember you have this exponential function e to the x. So, that percentage e is a Euler's constant, okay, 2.7182818, that is an Euler's constant. Then pi, pi is 3.1415927. So, in Scilab the value is it is represented as percentage pi. So, it is always in radians. Okay. Scilab uses radians only, it does not use your degrees. Now, percentage t and percentage f, they are Boolean constants which are representation of something is either true or false. If something is true, it is represented as percentage t, and if it is false, it is percentage f, and percent f is of course negative of true. So, it is tilde percentage t. So, this is true and false variables. So, these are called logical variables. In Fortran also we have logical variables, but we did not have too much occasion to use it. So, next, many times what happens, you get a very large number in your calculation. So, how will you represent? So, I think many calculators also give you infinity as a result if the number is very large. So, Scilab uses percent infinity, and sometimes your result is not a number. So, Scilab represents it as percentage nan. So, percentage nan is used to indicate not a number, NaN means not a number, and I already mentioned earlier that this double slash, it represents a comment character. Anything you want to write as a comment will be given as in Fortran it was first column C followed by all your statement. In Scilab it is 2 slashes and followed by the comment. So, this will not be read or executed in Scilab. Okay. So, now we will start matrix operation. Scilab is especially very good for doing all the matrix operation. So, in Fortran, remember you have to give lots of do loops to read matrices. In Scilab there is no requirement, because it assumes that every variable is a matrix unless you state it otherwise. Now, suppose I want to read a 3 by 3 matrix. Scilab makes it very easy. A equal to square bracket 7 to 4. Between 7 and 2 there is one space, between 2 and 4 there is another space, semicolon, then 1 2 4 semicolon, 7 8 9 semicolon. Okay. So, square bracket complete. So, this is a way to define a 3 by 3 matrix in a Scilab. How do you define a matrix in a Scilab? You did not give any dimension statement 3 by 3. The very fact that there are 3 numbers here, each separated by space, semicolon, next row each number separated by semicolon, then the next row, then bracket end. So, this way it understands it is a 3 by 3 matrix. So, matrix operations, as I mentioned, are extremely easy in Scilab. So, A equal to this, it assumes it is a 3 by 3 matrix. Now, how will you give a 4 by 4 matrix? 7 2 4 space 8. So, each of this, suppose I add an extra 8 here, here an extra add 3, then 7 8 9 some other number, then semicolon another 4 numbers. So, then it will be a 4 by 4 matrix. I do not have to declare the array. Depending on how many numbers are written between the semicolons and the square brackets, it assumes the size, it gets the size of the matrix through the data itself. So, now suppose I want the transpose of this matrix. Remember, in Fortran if you want to transpose, you will have to define each element of the transpose matrix as the suppose I want Aij is my element, the element of the transpose will be Aj. So, I have to define a new matrix and define every element of the matrix. So, Scilab it is very simple, B equal to A slash, so that particular prime A prime is the transpose. So, transpose is again very simple, one line B equal to A slash. So, this is how you get a transpose. Now, how do I do matrix multiplication? It is so trivial. Suppose I say A star B, the moment I say A star B, the product will be displayed on your screen. The product will be displayed on your screen, but suppose I want to write the product into some other matrix. So, I can do it like this, C is equal to, if I want the product to be written in some other matrix, I will say D equal to A star B. So, the matrix D will be the product of A and B. Now, if I want the inverse of the matrix A, C equal to inverse A, it will give the inverse of the matrix A. Now, you see what is my problem here, okay? C equal to inverse A, and if I say it will give the inverse, it will give an error because there are no slashes here. So, I should have put 2 slashes here because this is a comment, C equal to inverse A slash slash, it will give the inverse of the matrix, that would be a comment. Now, if I want the determinant D equal to determinant of A, it will give the determinant. So, what I will do, I will illustrate all these commands now and we will execute most of them. Okay. So, this is for the matrix operations. So, remember to get the inverse matrix, you have to write an entire Gauss elimination program which took several hours. So, in Scilab it is very, very simple, just one line statement. So, is it for determinant. Now, let us look at matrix diagonalization. For matrix diagonalization, okay, again it is a very straightforward process. So, first I will define the matrix. How will I define the matrix? A equal to into square bracket 1 4 3 semicolon 0 2 5 semicolon 1 3 minus 4 bracket complete, that means it is a 3 by 3 matrix. So, this capital A is a 3 by 3 matrix. So, what is the process of diagonalization? The process of diagonalization is from the matrix A, I want to get the diagonal form. AD is the diagonal form. What is the formula for the diagonal form? It is X inverse AX, where what is X? X is the matrix formed by the collecting all the eigenvectors in the form of columns of the matrix into a single column. That is, I take all the eigenvectors of A, arrange them in a column form. If I take all of them as normalized eigenvector, that is each vector is normalized. So, X is a matrix of eigenvectors, X inverse AX will be nothing but AD. So, that is my diagonal form. So, the Scilab command for getting the eigenvalues and eigenvector is, look at this command, square bracket LAM comma X bracket complete equal to B diagonal into round brackets A bracket complete slash slash. So, this is my command, lam comma X equal to B diagonal A. So, here lam is lambda D, lam is nothing but AD, that is the diagonal form of the matrix, and your X is the matrix of eigenvectors. So, with this one straight command, I get the entire diagonalization process that is illustrated in the next slide. So, once I execute that particular command, so it gives X is equal to 3 columns here, these 3 columns are the eigenvectors of the matrix, then lambda is the eigenvalue. Now, all the eigenvalues it is writing in a diagonal form. Okay. So, this is a diagonal matrix which consists of all the diagonal elements as eigenvalues and X is your matrix of eigenvectors. Now, here instead of lam comma X, I can call it by any other name. These are just variables. Lam and X are variables. Instead of lam, I could just call it WW. In place of X, I could call it Y. Okay. A is the name of the matrix. Instead of A, I could have it any other name, but this B diagonal is the command. B diagonal is the command. The results of B diagonal is lam comma X. These could have some other variable names, that is completely all right. So, this is how I shall execute the diagonalization in Scilab, again extremely easy. Now, let us see what is the next thing. So, instead of getting all the eigenvalues and eigenvectors, suppose I just want the eigenvalues. Okay. So, when I type B diagonal A, I got both lambda as well as the eigenvalues. Now, if I just say eigenvals is equal to spec into bracket A. So, it gives me only the eigenvalues. So, the eigenvalues were 5.9, 4.6, 3.2, let us check. Okay. These were the same as the earlier eigenvalues, except here they are in some order, whereas in the next one I have given in the order of the largest value first, next value largest in magnitude, next largest in magnitude and the third largest in magnitude. So, the eigenvalues are given here through this spec. Spec command gives me the eigenvalues of the matrix A. Okay. So, then suppose I want to define an identity matrix. To define an identity matrix, the command is EYE 5 comma 5. Okay. So, why do I say 5 comma 5? I want a 5 by 5 identity matrix. So, the moment I say EYE 5 comma 5, the answer is this 5 by 5 matrix. Okay. 1 0 0 0 0. So, this is the first row, second row, the middle second diagonal value is 1, third diagonal is 1, fourth diagonal is 1, fifth diagonal is 1. So, this is a 5 by 5 identity matrix. So, the moment I say EYE 5 comma 5, it gives this as an answer. Now, instead of writing on the screen, suppose I want to assign some other matrix with this particular identity values. So, I will say, let us say W is equal to I 5 comma 5. So, what it will do? W will be my identity matrix of 5 comma 5, it will not write anything on the screen. Here it is writing on the screen because I said I 5 comma 5 enter. So, it will give me all these results. Now, suppose I want a matrix of I want a null matrix of 4 rows and 8 columns. I will just say zeros 4 comma 8. So, what will this command do? It will have a matrix. This is not a square matrix, it is a rectangular matrix 4 rows and 8 columns. So, it will give 4 rows with 8 zeros in each of the rows. So, this is a zeros matrix. Okay. So, now let us see some other commands as well in Scilab. Many of the commands in Scilab also are similar to the Unix commands. Now, suppose I want to know the present working directory in the Scilab. I have downloaded Scilab. Okay. When you download the Scilab, it may put in a particular directory. So, if you want the present working directory, it will print the current working directory of Scilab. So, when you started the Scilab, if the default directory is C:/program files /Scilab 5.2.2. So, it will show this as the present working directory. ls, just like in Unix, it will list all the files in the present working directory. Now, you can always change directory using cd or chdir. Both these are commands to change the working directory from one to another. Suppose you want to change the directory, suppose your Scilab is in D drive, then you want to say cd d:/Scilab. So, it will go to the directory Scilab in the D directory. Now, another useful thing, when you execute commands in Scilab, there will be many commands you are going to execute and you will not remember the entire list of commands you have given because the screen keeps changing all the time. So, you can save all the commands using what is called a diary command. So, this diary command, okay, it saves the entire content of the Scilab work into one particular file. So, how do I go about doing this? When you start, say diary in bracket content.txt / bracket complete. Okay. So, once you give this command, it will start the diary. So, whatever commands you will execute on that day will all be saved in content.txt, and once you finish your work, then you will say, okay, now let us see, when you enter the command diary in single quote content.txt single quote bracket complete, you will be prompted, you will get answer equal to 1. That means, it has started the diary. Then you type whatever commands you wanted, you type to execute, you type all the commands. After completing the current work, now you want to close, you need to close the diary. So, what do? You use the command diary 0. Once you give command diary 0, it will save all the contents in this file content.txt. So, next time when you want to see what all commands you have used, you can edit, open this file content.txt, it will have all the commands that you used on that particular day. Instead of content.text, you can give any other name. You can give, for example, date, you give the date instead of content, so many contents will be there. So, one way would be you just give the date, say today is say 28th February. So, you say 28 Feb dot 28 Feb dot text. So, it will save all the commands of today into 28 Feb. Okay. So, now the next thing we want to do is to use these polynomials. Remember, polynomials are nothing but functions where variable x is raised to large number of powers. Okay. So, now suppose I want to find the roots of a particular polynomial. Okay. When I want to give the roots of a polynomial, there are two different ways of doing it. Okay. So, do not look at the first one right now. The first command really generates a polynomial. Okay. The first command generates a polynomial. So, let us not go to the first one, let us go to the second command, coefficients p equal to 3, 2, 1. So, what this does? It generates a polynomial. Okay. So, this coefficient knows that polynomial has 3 particular terms. So, when it has 3 particular terms, it understands that it is 3x square plus 2x plus 1. So, that is what is your polynomial. Then you can find the roots of that polynomial. Okay. So, this particular set of statements p equal to 3, 2, 1, it generates a polynomial of 3 terms. The highest power will be the third term. So, 3x square plus 2x plus 1. Suppose I want a third order polynomial, I will say p equal to 3, 2, 1, 4. So, if there are 4 terms, the first term will be the x cube term. So, you give the coefficients of the polynomial. When you say roots p, it will give you all the roots of the polynomial. Okay. Now, suppose you want to generate a polynomial. Okay. So, this p equal to poly, it generates a polynomial. So, p equal to poly generates a polynomial. What this will do? It will generate a polynomial x whose roots are 1, 2, 3. Okay. So, you execute both the poly command as well as coefficients command to solve polynomial equations. Okay. So, this is the same thing here. I gave the coefficient of the polynomial, find out the roots. Okay. Now, in this case, p equal to poly, all these commands. So, these are the roots of my complex polynomial. So, these are the roots of a complex polynomial. So, from that I can generate a polynomial. So, but I think this polynomial coefficients, what was my earlier one? Okay. Giving the coefficients and finding roots is a much better option. So, use these commands p equal to 3 to 1 and roots p to find the roots of equations. Okay. So, next now we will slowly go to slightly more advanced topics now. So, suppose I want to generate functions in a Scilab. Just as in a Fortran you have generated a function, I can also create a function in a Scilab. So, how do I do that? You define a function by using the following command, function value equal to function x and then value equal to exx plus ex minus f comma end function. So, these two lines together define a function. So, the first line says I want to declare a function. I want to declare a function called function x and that function x will be given some value and the second line says value equal to exx plus ex minus f comma end function. So, function and end function, whatever is given between these two is the function definition. So, I define a function in this manner. So, once I define a function, suppose I want to calculate function x equal to 0.5. So, when x is equal to 0.5, I type func into bracket 0.5 enter, then it will calculate this function value when x is equal to 0.5. Okay. So, suppose I want the function at x equal to 1, I will say func is equal to 1. So, this way I define a function and estimate the values of the function for all values of x given in the bracket. This is how a function is defined. Okay. Now, your next question would be, can I do subroutines in Scilab? In principle, yes, but the commands will be far more involved. So, before I go to other uses, we should know how to program in Scilab. You know, in Scilab I can also do programs. So, there will be commands. So, you can treat this function as the program lines in a Scilab. So, now suppose I want to do an integration using Scilab. Okay. So, whatever numerical methods we used in our earlier part of the course, like interpolation, integration, matrix operation we have seen, polynomial you have seen, now integration, differential equation, all this you can also do in Scilab. So, I will illustrate now how to integrate. Okay. Integration is also quite simple. So, now when I want to integrate, I have a variable t, it takes on values from 0 up to 1. So, t takes on values between 0 and 1, spacing is 0.01. Okay. So, how do I define that? This is like a do loop, do something from 0 to 1, spacing 0.01. So, 0 colon 0.01 colon 1, that means t takes on all the values between 0 and 1 with a spacing of 0.01. So, what will be the values? 0, 0.01, 0.02, 0.03. Okay. It will have all the 101 values between 0 and 1. Now, if I want to integrate this using trapezoidal rule, I will say int trap into bracket t comma x t. So, you will get the answer. Okay. So, this simple integration using trapezoidal rule, just one particular line integrate int trap t comma x t using a trapezoidal rule. This is where I get the answer. So, in place of exponential t, I can use any other function. So, now let us see how to do the same integration in Scilab using the programming statement. Okay. So, the next one, I am going to do trapezoidal rule using some programming statements. Okay. So, how do I do? N is equal to 101, these are data points, a equal to 0, that is my initial value, b equal to 1, that is the end point. Now, I will define a function. How do I define a function? Function value is equal to function x, comma, value equal to exponential x, comma, end function slash slash. Okay. So, this is how I have defined a function. Okay. Now, next I will define h, which is the spacing. What was the spacing here? It was 0.01. So, b minus a divided by n. Okay. So, n I should define n here, n is already defined at 101. So, this is the spacing between the points. So, next is sum trap equal to 0. So, this is my initial value. Now, I am going to write a program now. I define the initial value and these are comments. What is the comment? Initialize for trapezoidal rule. Okay. So, I initialize, then I will use a do loop. How do I use a do loop? For I going from 1 to n. Okay. So, this is the beginning of my do loop. Okay. So, this is like a do I going from 1 to n in Fortran. So, I am using a for statement. In C++ and other languages, in place of a do, they have a for statement. Okay. So, this is the beginning of a do loop, for I going from 1 comma n. Then I want to put all the sum of the function into this sum underscore trap. Sum underscore trap is equal to sum underscore trap plus function of a plus I minus 1 into h. So, what does this do? My do loop goes from 1 to n. So, the first value of the function is the value of a, the initial point. Second value, when I equal to 1, it is I minus 1 is 0. So, function of a, that is the first value. Next time when I go to the do loop, I is equal to 2. So, 2 minus 1 is 1. So, this is h. Next value of the function is a plus h. The third value of the function is a plus 2h, then a plus 4h, all the way up to n is equal to 101. The last value will be a plus 100 times h and h 101 100 times h. So, this will be the last value. So, I add all the last values and how do I end the do loop? Semicolon end. So, this is how the do loop ends. So, when the do loop ended, I have added all the values of the function. So, to get the integration using the trapezoidal rule, integral is equal to sum underscore trap, this was the sum, into h by 2. So, this is my integral using the trapezoidal rule. So, this is what I have done through this. I have also illustrated how to program using Scilab. It is very similar to Fortran, except your do loop, in place of do, you have a for statement, functions are defined slightly differently, and very close similarity with the Fortran as well. Okay. So, So, now I will, before I conclude, I will do a small integration of sin x. So, what I want to do? I want to integrate a sine function over the range from 0 to pi. So, x 0 is equal to 0, x 1 goes from 0 spacing 0.1 up to percentage pi is pi. So, x 1 is a variable which goes from 0 to pi, x 0 is my starting point. Okay. So, my capital X integrate sin x, x comma x 0 comma x 1. Okay. So, my x 0 is my initial value, x 1 is a vector, x 1 is a vector which goes from 0.1 up to pi, and my x is also a vector. So, I am going to integrate sine function, okay, from x 0 to x 1. So, there will be x 1 is a vector whatever 101 points. So, I will get an integral of sine x for every range in that integration. So, 0 to x 1 sin x dx. So, the printout will be a vector x and 101 values of the integral of sin x between 0 up to the upper value of the function. So, sin x is your function. So, you can integrate this way. You can also integrate any other function in place of sin x. So, this is how you will do integration just by integration command. So, in place of sin x you can use any other function. So, I will conclude this lecture today, and later tomorrow I will start solving differential equation using Scilab. Not only we will solve differential equation, we will solve many other problems using Scilab, and I will also demonstrate the use of this in the next lecture. We will conclude here. Thank you.